Hello, today's video is module 14.2, polygons in the coordinate plane. We will be working from pages 407 to 412. So if you need to pause the video to get your math book, please do so, and I'll see you on page 407. Okay, before we start on page 407, I wanted to give you a few notes. First of all, we will be covering standard G3. I can draw polygons in the coordinate plane given the coordinates for the vertices. What is a vertice? That is the corners where two sides meet. So basically the corners of the shape. And I can use coordinates to find the length of a side of a shape and the area of the shape. All of this being done on the coordinate graphing plane. So let's go through just a few definitions. First of all, what is a polygon? A polygon is a closed figure, or a shape is another word of calling it, on a flat plane. That means it's two-dimensional. If you think about three-dimensional objects, you think about being able to fill something up with water. A two-dimensional object is a flat surface, like the top of a desk or the front of a door. So a polygon is a two-dimensional shape. It is closed. It has straight sides. And the sides meet at an endpoint, or endpoints. Every side will meet at endpoint. A regular polygon has equal sides and equal angles. And vertices, which I've already mentioned a little bit, the singular for that is a vertex. Vertices are the plural form, and that are the corners where two sides meet on a shape. That is the corners of the shape. Note, the number of vertices is equal to the number of sides of a polygon. So for example, a polygon with 3 vertices is a triangle. Move this up. A polygon with 4 vertices would be a rectangle or a square. Or if you think about it, it could also be a rhombus or a trapezoid, what we learned about in our last unit. A polygon with 5 vertices is called a pentagon. It has 5 sides. A polygon with 6 vertices is called a hexagon. What is a polygon with 10 vertices called? So you can add that to today's homework and get 1 extra credit point if you can tell me what a 10 vertices polygon is called. Okay, I'm going to go under the document camera, so I will see you there for page 407. Okay, I'm going to be working from page 407, and this is about drawing polygons actually on a coordinate plane, which is what we have here in front of us. So we have a shape. Let me read what it says here. It says, Caleb, no, that's the wrong page. Go back a page. It says, Sheila wants, that's the bold lettering. Sheila wants to make a pattern of 2 different tile shapes on a floor. She first graphs the shapes on a coordinate plane. So that there's an A and a B. So A is shape 1, and these are the coordinates of that shape. So this is kind of fun. It's just connecting the dots once you plot your coordinate points. So we're going to plot our points. Remember, this is your x-axis, and this is your y-axis. So point A is 3, 5. Remember, the 3 is the x. The 5 is the y value. X is always first. X comes before y in the alphabet. It also comes before y in coordinate graphing points. So A is 3. So remember, when you're doing these coordinate graphs, if you make your own at home, always put the numbers on the lines, not the spaces. That'll really mess you up. So we have 3 is our x value, and we have to rise up to number 5 and see where those two meet. Always a good idea when you're graphing these to put the point name A, to also put the coordinates of the point. Get in the habit of starting to do that now. Point B is 4, 6. 4 is my x value, 6 is my y value. I find 4, and I have to go up to 6. That's point B, and the coordinates are 4, 6. Point C is 5, 5. 5 is my x value. 5 is my y value. Here is point C, and that's 5, 5. And then point D is 4, 4. 4, 4. Right here. That's point D. That is 4, 4. Now I'm going to take my ruler, and I'm actually going to use pink because it's a little brighter color on the camera here. And I'm going to connect my dots. Use a nice straight edge so that I get a really nice shape here. So we can see that this is going to be some kind of quadrilateral, a rectangle, a square, a rhombus, or a trapezoid, right? It's got 4 sides. We know it's not a trapezoid because the sides don't look like they have one shorter and one longer, do they? So now we have to, what is it asking us to do? What shape did we form? Well, all the sides, if you look at this, should be the same length. That's 1/2 inch. That's 1/2 inch. That's 1/2 inch. And that's 1/2 inch. So a figure, a polygon that has 4 equal length sides and 4 vertices is called a, yes, that is a square. So the first question on A says the polygon formed is a square. So let's write that. This is letter A. The polygon formed is a square. So that's letter A. And now we're going to do letter B. So it's a different shape. So I'm going to switch papers. Put that one there. We'll take this one away. Straighten this one out. There we are. Page 407, shape number 2, letter B. You're given all these points. P, Q, R, S, T, U, V, W. I kind of ran out of room, so I went down here. So with these shapes, or these points, we are going to make a shape. So let's start plotting our points. So point P is -5, 2. Remember, the X is first, and the Y is second. So we're going to do, this time we're in the negatives, so we're going to go to quadrant 2, -5, and we have to go up to 2. So -5, 2 is right here. That's point P. Don't forget to label it and write its coordinates next to it. Q is -4, 3. -4 is my X value. I have to go up to 3 where they meet. That's Q, and that's -4, 3. And R, 0, 3. Well, where's 0? Right in the center. This is our crisscross spot. That's 0. 0 and then up to 3. So this is right on the y-axis. This is point R. I'll just put it over here. 0, 3. S is 1, 2. X is 1. Y is 2. This is point S. 1, 2. Then we have point T, which is 1. Now look at that. T is 1, -2. 1, so we have to go which direction? I'm going to move it up, down just a little bit here. Down to -2. So that is going to be T. That is 1, -2. Now we do U. U is 0, -3. 0 is my X value. -3 means I go down to -3. This is also on the y-axis, just the other side of it, right? So that is point U. Put a little arrow. I can really see that now. That was 0, -3. See that? So I just wrote that there. Now maybe I can get up a little higher here. V is -4, -3. -4, -3. After you do these a little bit, you get pretty good at them. V is -4, -3. You'll be doing a lot of these kind of points for a lot of your math classes now and in high school. W is -5, -2, -5, -2. So it's a good idea to start getting used to plotting all of these things. So if you want to work on that at home a little, plotting some of these, it's a good idea. Okay, I think we got all our points. So now we got to connect our dots. So we're going to connect P to Q, Q to R, R to S, S to T, right there, T to U. You tell what shape it's going to be. U to V, V to W. Oops, my ruler slipped. And W to back to P again. All right, what kind of shape do you have? That's the second question. That's letter B. How many sides do we have? How many vertices? 1, 2, 3, 4, 5, 6, 7, 8. What is an 8-sided figure called? Well, what is an 8-legged creature called in the ocean? Right, that's an octopus. So this is an yes, octagon. So that is an octagon. So that was letter B on page 407. Now we are going to move on to page 408. If you need to pause the video, go ahead, and then we'll be on 408. Okay, this is page 408. Now we're going to be finding perimeter. Remember that perimeter is the distance all the way around a shape, not the area, not the inside of the shape, just the area around the shape. So example 1 on page 408 says the grid, which I've drawn here and I'll show you. The grid shows the path Tommy followed when he walked from his home at 0, 0 to various locations and back home again. If each grid square represents 1 block, how many blocks did he walk? Okay, so they're giving you some points, coordinate points there. And notice how they started at the corner. So our 0, 0 is really right here, isn't it? That's our 0, 0 point. And how do I know that? Well, this one is not worrying about the ones going to the left or the ones going down. So we haven't even shown those. We've only shown the corner up and the corner to the right. So that's why we don't have the full coordinate plane there. We don't need it. So the home is at 0, 0, so we're going to label that. I think I'll go back to green here. This is the home, 0, 0. The library is at 0, 4. So this is the library, 0, 4. And the park is 5, 4. So look at how I didn't put all the numbers, did I? But you can figure out what number this is in between. So this is 4. This one has to be right, 5. So we need 5, 4. 5, 4, and that is called the park. Park, 5, 4. Then we have friend's house, 5, 2. So this is 5, 2, friend's house. 5, 2. And the pond is 7, 2. 7 what? 7, 2. 7, 2. Oh, friend's house is here. Oops. Friend's house. My error. 5, 2. Hope some of you out there noticed that. So this is not the friend's house. This is the pond at 7, 2. Let's change that. And I don't know if my whiteout works too good. We'll try it. Gotta cover it up a little bit. Okay, so friend's house we got. And now 7, 2 is the pond. I'm gonna come up this way and write pond. There, because my stuff isn't drying. And then we have the store at 7, 0. That's our store. That's 7-0. Okay, we have our map labeled. So now we have to, what do they want us to do? How many blocks did he walk all together, right? So we have to figure out the perimeter from here and back home, right? So we need to find the perimeter of this whole thing. We have to add that all up. So we have to figure out what those numbers are. Well, each unit represents one block. So one of these squares is one block. Two of these squares is 2 blocks. 3 is 3 blocks, and 4 squares is 4 blocks. So the length of this side right here is from 0 to 4. That is a total of 4 blocks. I'll write it sideways. 4 blocks. How far is it from here to here? Well, we can count, right? But you could also look at your coordinate points and you could say, well, the 4s are going to be the same. So you only have to do is subtract the absolute value of 5 minus the absolute value of 0, right? Which is 5, right? 1, 2, 3, 4, 5. So this is 5 blocks. And if you go from here to the friend's house, did I do something wrong? I don't think so. Park to friend's house. You know what? My friend's house seems to be off. No, it's right. 5, 2, and the park was supposed to be at 5, 4. Yeah, that's right. Okay, so now how many units is that? Exactly, that's 2 blocks. 2 blocks. Hope you can see that. How many units is that? 2 blocks. That one's a little messy because of my error. And from here to there is also 2 blocks. I'll abbreviate 2BL. And then how far is it from here to here? Well, we went from 0 to 7, right? Or from 7 down to 0. 7 blocks. Now to find the perimeter, we just add all those up. So if I'm going to add that up, I'm going to start with here. I'm going to have 4 a little bit, plus 5 plus 2 plus 2 plus 2. Don't get mixed up how many 2's you need. Plus 7. Add that all up, and you should get 22 blocks. That's the perimeter of that shape, or the distance that, what was his name? Tommy walked all the way around that shape. Okay? Okay, this is page 409. That's a little blurry if I can focus that. Example number 2. Finding the area in the coordinate plane. Our last one was finding the perimeter. Now we want to find the area. Now I wanted to show you, they do have a coordinate plane drawn out for you. I wanted to show you that you can put your X and Y axis anywhere on here. I just wanted to show you that you don't have to start at the corner, and you don't have to start in the middle. You can start your Y and X axis anywhere according to whatever the problem is telling you it needs. So in our case, we only need the positives, but I just wanted to show you that you could make your X and Y axis in different spots. You don't have to get stuck in the same old spot. So now we want to plot our points. So let's read the problem first of all. Caleb is planning a new deck for his house. He graphs the deck as polygon ABCDEF on a coordinate plane in which each grid unit represents 1 foot. So each little square is 1 foot. The vertices of the polygon are, and then it lists the points that I have up here for you. And it says, what is the area of the deck? Now, area is how many squares are going to fit inside of his deck. So this is a little bit weird, but let's do this. So let's first plot all our points. So have to make it so we can see it. I don't know if I can get it any taller than this. I'm going to try. No, I don't think I can. So A is 1, 0. So we have to come down here every time to do this. 1, 0 is going to be right there. This is 1. This is 0 on the y-axis. So that's point A, 1, 0. Point B is 3, 2. So 3, 2. That's point B, 3, 2. C is 3, 5. 3, 5 is way up here. C, 3, 5. D is 8, 5. We gotta go all the way to 8 and up to 5. D is 8, 5. E is 8, 2. 8, 2. This is E. Oops. 8, 2. I'm gonna get rid of my little mess there. 8, 2. I can do that. Okay. And then F is 6, 0. 6, 0 right over here. That's F. 6, 0. Okay. Connect our dots. So I'm going to go, and I'm going to do something a little different here. Dot, 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 dot. A to B, and then B to C, and then C to D, and D to E, and then E to F. I'm going to go dot, dot, dot on those last two. Okay, because they want to know the area of his whole deck, okay? So we need the area of the parallelogram here, and we need the area of the rectangle here. So we have two areas to calculate here. So first step is find the area of the rectangle. So area of a rectangle is equal to base times height, or length times width, right? So what is our length? What is our width? We have to figure that out, don't we? So I'm going to just put another little dashed line in here. Okay. So now let's see, what is this length or this length? They're the same because it's a rectangle. So we can count, or we can say, well, we know that we're at 5 for the y values. So we could just subtract the absolute value of 8 minus the absolute value of 3. And what would we get? Well, we can count 1, 2, 3, 4, 5, right? So to figure that out, we take the absolute value of 8 minus the absolute value of 3. And why do we subtract the absolute values? Because we're in the same quadrant. If one of the points was over on the other side of the y-axis, then we would have to add the absolute values. But because they're in the same quadrant, we subtract, and we get 5. And each unit was, again, I got to look. Does it say each unit? 1 foot. So each one of these units is 1 foot, so 5 feet is the length, right? That's L, times W. How do we find the width from here to here? Well, they're both on 8, so we have to take the absolute value of 5 minus 2 because they're in the same quadrant. So 5 minus 2 is 3. So the area is 5 times 3, 15 feet. That's the area of the rectangle. And it's, don't forget the little 2, it's feet squared, right? Or you can say square feet if you don't know how to make that little 2. Okay, then we have to do the area of the parallelogram. The area of a parallelogram is base times height, right? So what is our base? This is our base, right? So what do we have? We have a 6, a 0, and a 1, 0, right? If you can't see that. So we have gone 6, absolute value of 6, minus absolute value of 1, 5 units. We can count 1, 2, 3, 4, 5 units. So I'll write that. Absolute value of 6 minus the absolute value of 1 equals 5, right? Feet. That is the base. B. Now we have to be careful on this. We have to do the height. An angle is not the height. An angle is not the height. When you go to the doctor, you don't lean against the wall in a weird angle. You go straight up and down with your heels next to the wall, right? So this, I'm going to put that in orange. This is the height, right? So how many units is it from here to there? 1 unit, 2 units. So times 2, right? That's your height. Don't get messed up and count this is your height. Plus, this is at an angle, and you haven't been given the formula yet to figure out the length of this side. So you will, but you haven't yet. So there's really no way for you to figure that out with the math tools you have at the moment. So 5 times 2, 10 feet squared, or square feet. And then we have to add those two areas together. 15 plus 10 is 25 square feet, or feet squared. So that is our answer to example 2. If you need to pause the video and get this down, go right ahead. I'm going to move on to guided practice, page 410. Okay, we're going to go to page 410, guided practice. I just wanted to make you aware, if you look at my background back here, what is that? Exactly, that's a coordinate plane with all 4 quadrants. If you look, quadrant 1, 2, get out of the way, 3, and 4. So just trying to have a little fun here. I've probably been quarantined for too long here. So anyways, let's go to share our screen. And here's page 410. So we are going to, I'll move myself down here. We are going to read these and do these together. So if you got a pencil, get it out, work with me on these. So number 6 is a graphic designer creates letters for wall art by first graphing the letters of a polygon. Let me get my stick here. Letters of a polygon on a coordinate plane. One of the letters is polygon MNOPQRSTUV with vertices, and then it gives you each coordinate for MNOPQRSTU and V. And then each grid unit represents 1 inch. So graph the points on the coordinate plane and connect them in order. What letter is formed? Okay, we got a tiny spot. So I think what I'm going to do is enlarge this so that we have a bigger spot. There, that's better. Now we can see it a little bit better. So we're going to grab our little tool here. We're going to do point M is 2, 1, 2, 1. And this is a small grid. I don't know that I'm going to be able to label everything on there. I'm just going to put the letter by it and not the point. N is 2, 9. 2, 9. That's N. O, 7, 9. 7, 9. Yep. That's O. P is 7, 7. 7. Let's stay in the right spot. That's P. You can go ahead and graph this with me as I'm doing it. Q is 4, 7. 4, 7. Or if you want to pause the video and do it ahead of me to make sure you get it right. And then check your answer when I get done with this. 4, 7. Okay. R is 4, 6. That's R. Q doesn't look very well drawn. Neither does R. S is 6, 6. 6, 6. My goodness. It's going to be all crunched up. T is 6, 4. There's T. U is 4, 4. 4, 4. This is really going to be crunched up. That's U. Should have done this under the dot camera. V is 4, 1. My goodness, right here. Okay, if I was to draw that and connect all the dots, what would I get? Oh, you know what? I'm doing the wrong page. I'm doing your homework for you. Oopsie poopsie. Okay, so I didn't mean to do your homework. I meant to do the guided practice. So this is page 411. So now you've got a little heads up on how to do that. So you would connect the dots would be the next one. So I don't want to go any further with this because I want you to do that as homework. So I'm going to clear the drawing and I'm going to open up the other page. 400 and this one here. There we go. That's the one I want to do. Okay. We're going to come back to that 411 anyways at the end, and I'm going to give you some hints for that. I've already given you some hints now by plotting all those points for you. Okay, a gardener uses a coordinate grid to design a new garden. The gardener uses polygon W, X, Y, and Z on the grid to represent the garden. The vertices of this polygon are W, X, Y, and Z. Each grid represents 1 yard. I'm going to move this down here. Just want to make sure. Okay. So we are going to plot our points, graph the points, and connect them in order. What is the shape of the garden? Well, we have to find our little tool. W is 3, 3. 1, 2, 3. 1, 2, 3. 3, 3. This is W. And I might have room to be able to write this on here, I'm hoping. 3 and 3. X is negative 3, 3. 1, 2, 3. 1, 2, 3. This is X. And X is, what was it? Negative 3. 3. Sorry for the messy mess. Trying. And then Y is negative 3, negative 3. 1, 2, 3, down 3. 1, 2. Look at how you're going to get a point in each quadrant. Wow, that's exciting. Okay, Y is then negative 3, negative 3, negative 3. And then Z is 3, negative 3. 1, 2, 3, 3, negative 3. And that's Z. And that's a 3, negative 3. Okay, now we got to connect our points. So I'm going to use a line for that. So X to W, W to Z, X, W, X to Y, and Y to Z. So we get a nice, what is that? Probably a square, right? The sides all look like they're the same length. Graph the points. What is the shape of the garden? Well, we just answered that question. It is a square. Oh, I want to use red. I want to use red. Square. S-Q-U-A-R-E. Square. Okay. That's the name of the shape. How much fencing will the gardener need to enclose the garden? So to figure out the fencing, he wants to put a fence around the outside of the garden. So that's a hint that we're going to find the perimeter of the garden. So we need to find the length of each side. Well, since it's a square, we know that every side is the same length. So we only really have to find one length. But let's just double check it. Each side of the garden is blank yards in length. Well, let's count. We have 1, 2, 3, 4, 5, 6, right? Another way of doing that, and I'm going to show you both ways. So this is a, I'm going to change colors now for that. This is 6, what is it, yards, was it? Each unit represented a yard. Yes, so this is yards, YD. YD. And then let's just count to make sure. 1, 2, 3, 4, 5, 6. This is also 6. Then we know that the one opposite across is going to be 6, and the opposite across here is going to be 6 yards as well. Now let me just show you the formula for doing this. So if you weren't plotting the points and counting the squares, you could figure it out using the coordinate points to figure out the length. So we know that these are both -3 in the x, right? So we need to find out the distance from top to bottom. So to do that, we take the y coordinates, and now notice how they're in separate quadrants. This is quadrant 2 on this side. This is quadrant 3 over here. So we're going to have to add the absolute values. If you get confused on that, go back to the previous lesson and watch that, because that shows you how to do it without having to plot out the points. So I'm going to take the absolute value of 3, the top point, plus I'm going to add the absolute value of the bottom point, which is -3. And the absolute value of any number is always the positive value, so it's really 3 plus 3. So the absolute values of the two are going to give me a +6, which we got anyways because we counted. But just in case you're not plotting everything and you get the points only, you can figure it out mathematically what the length of this side is by using that absolute value formula. So now it says each side of the garden is 6. Now I gotta go back to my red here. Each side of the garden is 6 yards, right? And now what's it asking? The gardener will need blank yards of fencing to enclose the garden. Well, how do we figure that out? We decided that was the length all the way around there, right? So we have to add that all up. So if you add 6 plus 6 plus 6 plus 6. Another way of doing that is just to take 4 sides times 6 yards. So 4 sides times 6 yards each is equal to 24 square yards. Yes? And I can move that over a little bit so you can see that a little bit better on the line. The answer is 24. Okay. Okay, what is the area of the garden? I'm not going to scroll down right now because it'll remove all my drawings, or it'll keep my drawings but move them all in a weird spot. So what is the area of the garden? Well, the area of a square is length times width, or base times height. So let's do that. Area is equal to length times width. Well, the length and the width are 6 for everything, right? So the area is going to be 6 yards times what? 6 yards. 6 times 6 is equal to 36 yards squared. Make this a little longer so it doesn't go to a different side. Squared. That's cute. Square yards. 36 square yards. Square yards. I'll do it that way. So that's the area of our garden. Okay, number 4. I'm going to actually do that one under the document camera because like the one I started doing, that was your independent homework, that was all crunched up together. So I'm going to do the next one under the document camera so that we can see things a little bit better. So I'll meet you there in just a moment. Okay, this is guided practice, page 410, number 4. And I actually wrote the points we need to plot down here. So if that was a good idea or not, hard to see them all at once. We'll try. So we have to plot, let's read what it says here. A clothing designer makes letters for varsity jackets by graphing the letters as polygons on a coordinate plane. One of the letters is polygon A, B, C, D, E, F. The vertices of the polygon are listed here. Each grid unit represents 1 inch. So each one of these squares is 1 inch. Graph the points on the coordinate plane and connect them in order. Identify the letter formed. Then find its area. Okay, so we are going to do that. And this is just like number 6 that I started doing and then stopped. So point A is 3, -2. So 3, -2. Just have a little bit more room to put these here. 3, -2. Point B is 3, -4. Same spot here. We just got to go down to -4. 3, -4. Point C is -3, -4. -3, -4. Point C, -3, -4. Point D, -3, +4. -3, +4. That's point D, -3, +4. We're in, looks like we're going to be in all the quadrants. E is -1, 4. -1, 4. And then F, -1, -2. Oh, we won't be in all 4 quadrants. -1, -2. Correct? I believe it is. Yep. -1, -2. So that's F. -1, -2. Okay, now we got to connect the dots. It says in order. So remember when you were like a kindergartner and you get those dot-to-dot, connect the dots books? Weren't those fun? And they make these cool pictures. Kind of get to do that again now, only in middle school. So we're going to connect A to B. We're going to connect B to C. We're going to connect C to D. We're going to connect D to E. And E to F. And one more. F back to A. Okay, what letter did I make? Maybe I should color it in, sort of color it in. What letter is that? I don't want to color in everything and color over everything I've made, but can you tell what letter that is? Exactly, that's the letter L. So number 4, the first question says, what letter did you make? You made the letter L. Now we have to figure out the area. Well, here's where, I'm going to grab another color here. We have to figure out how many squares fit inside this. Well, we could just count them, couldn't we? Yeah, in this case we could, but let's see if we could do it mathematically. So we have a rectangle and another rectangle. So we are going to have to draw a line right there so we can make 2 separate rectangles, right? So now we have rectangle 1 and rectangle 2. So what is the length of rectangle 1? We're going to call this rectangle 1 and this rectangle 2. So what is the length of rectangle 1? Well, this is width, right? Length is that. So length is going across. So this is going to be 2 units, right? We could figure that out by saying, okay, it's the absolute value of 3 minus the absolute value of 1 because they're in the same quadrant, right? So that's going to be 2, or we could just count. It's 2 units. How long is this from here to here? Now we're in separate quadrants, right? Notice how the -3s are the same, but the 4 and the -4 are different. So that's going to be the absolute value of 4 plus or minus. Yes, plus the absolute value of -4 because we're in 2 separate quadrants. Here's our dividing line, right? Quadrant 3, quadrant 2. So absolute value of 4 plus -4 is going to be 8. Let's count. 1, 2, 3, 4, 5, 6, 7. Oh, we went too far. This whole thing is 8. So from here to here, this is really -2. So it's absolute value of 4 plus -2. So it should be 6. 1, 2, 3, 4, 5, 6. So 6 is the length. I went all the way to the bottom. You only need to go to here because we're making it 2 separate rectangles. So now the area is 2 times 6, length times width. So area of rectangle 1 is equal to 2 times 6, 12 units, right? Which each unit represented, I think, wasn't it an inch or something? Each unit represented an inch. Yes. Oh, book fell here. So that's 12 inches. Then the area of the second rectangle is this one. So we have to go from here to here. So this point, let's just put this point in here. It's -3, -2, right? That point. So now we have to figure out our length across and our width up and down here. Base times height, same thing. So we can use these points or we can use these 2 points. Doesn't matter. So let's go to these 2 points. They're both blue. So we have the -4s are the same. We're in different quadrants, quadrant 3 and quadrant 4. So we got to take the absolute value of the x values. So that would be -3 absolute value. And we have +3 absolute value. We have to decide what goes here, a plus or a minus. Exactly, a plus. Why is it a plus? We're in 2 separate quadrants. And if we add it up, we get 6, right? Let's count. 1, 2, 3, 4, 5, 6. So the area of the second rectangle, the length is equal to 6 times now the width is the absolute value of -2 and -4. Subtracting this time because they're both in the same quadrant. So it's the absolute value of -4 minus the absolute value of -2, which is really 4 minus 2, or 2, right? So this is 2. This we decided was 6. So 2. 6 times 2 is 12 inches. Now to figure out the whole area, we have to add 12 plus 12. What does 12 plus 12 give us? Exactly 24 inches squared, or square inches. That's the area of that L shape. Now, like I was telling you, without doing math, you could just count these, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we could just count 24 squares as well. But when you get really big shapes and really big dimensions, you can't draw those. So then it gets more complicated, so you need to know the math. So that's number 4. And I'm going to come back to the page now. Okay, now we are back to the page. And number 5, we just did number 4. We did that under the dot camera. Number 5, how can you use a coordinate plane to solve perimeter and area problems? Well, how can you do it? You're going to plot all the points first, right? You want to do that first. Then you have to find the length of each side, right? So for perimeter, you have to add all the side lengths. Move this, make it longer. For area, you have to multiply the length times the width, or whatever formula you need. If it's a triangle, it's 1/2 the base times the height. Trapezoid, it's 1/2 base 1 plus base 2 times the height, right? Those kind of things. So you have to remember your formulas for that. Now, I'm almost done here. I want to go back to where I was on page 411. So I want to make this half the size now. I'm going to clear my drawings. So this is what I started doing, and I started plotting all these points on there. So you should be able to have those plotted now for yourself. Now it says graph the points on the coordinate plane. We did that together, and then connect the dots. We didn't connect the dots. So what letter is formed? Exactly the same as the one I just did under the document camera where we formed an L. This will be forming a different letter. So the designer will use decorative tape to paint the outline of the letter on the wall. So I have some hints for you here. Let me bring those up. So here's your homework, first of all. You have to do guided practice page 410, turn that in. You should be able to have that just done because you watched the video. So, and then independent practice is page 411, which is what I have on the left side of the screen right now. It's optional. You can do page 412 if you'd like to do the hot problems. It's 2 extra credit points for that. As well as I had asked you at the beginning of the video, what is a polygon with vertices called? And I wonder why I can't move this. Here, I'm going to move this a little bit. What is a polygon with 10 vertices called? So 1 extra credit point if you can tell me that. Put that on your homework. So homework hints. Now this is what I was talking about. So 6A is graph the points and connect the dots. 6B, they're asking you to find the perimeter. 6C, and I'll share these notes with you. 6C, they want you to find the area. They don't really come out and say that. That's what you're doing. How much space does the letter cover on the wall? That's asking you to find the area. To do this, you're going to have to divide the letter into, I don't know why I can't move over more. I'll just do this a little bit. You're going to divide the letter make it into 4 separate rectangles. So we did 2 rectangles, 2 separate ones on the example number 4 on guided practice page number 4, page 210. But you're going to have to make 4 rectangles for this one and add up the areas of each. So 7C looks like it might need a little bit of a hint. 7C is asking you, I'm going to move this back again for a minute. 7C is a line can be divide the figure into 2 identical 4-sided polygons. Each polygon has 2 bases and one base is twice the length of the other base. Identify the polygon and give its perimeter. Well, I'm going to draw that for you. If you draw a line right across the center, what shapes do you have now? Right, you have 2 trapezoids, right? So 7C, your hint is to draw a horizontal line across the center and tell me what shape that is. Then they want you to find the perimeter. So they want you to find the perimeter of each shape. So the perimeter is this, and you have to find the length of this side right here using counting your squares or using your formula with the absolute value. And number 8B is or 8A, the y-axis is considered, let me just go to that now. 8A, the y-axis right here, let me draw that. This here is one of the sides of that shape, okay? The polygon names the shape of the floor. So the y-axis is considered a side, and this is a 6-sided figure. Let's count. 1, 2, 3, 4, 5, 6. I think 1, 2, 3, 4. Yeah, 6-sided figure. It's not a regular polygon, but it is a 6-sided polygon of some sort. So what do you call a 6-sided polygon? So that's the question they're asking you. B is find the perimeter, and C is find the area. So hopefully that helps you with your homework. And if you have any questions, please email me. In the meantime, we'll be doing online sessions so that you can also get a lot of your questions answered on the homework. So I hope you have a good day, and we will see you soon. Bye.